Okay, here's the totally general 2x2 system, and I think it's a little bit instructive to solve this. There's some interesting structure, the solution, some interesting special cases. So I'm gonna go through quickly. I'm gonna probably, you'll have to kind of work through the details on your own, but okay, let's make the augmented matrix. And then the first thing I'm gonna do is scale row 1 to put a 1 right there. So let's scale it down by 1 over A, divide everything through by A. By the way, this introduces an implicit assumption here, which is that A is not 0. So you should think about what happens if A is 0, in which case you'd want to switch the first and second equation, right? Because you're always trying to put the non-zero number at the top left. But when we think about that, so if I scale the first line by that, and then, okay, so then, right, then you'd want to subtract C times the first row from the second, right? So row 2, we're going to do minus C times our row 1. And if we do that, I get the first row doesn't change. That becomes a 0. This is still B over A. This is a little uglier now. It's D minus BC over A, R over A. And this is S minus RC over A. Okay, then it's worth maybe scaling up by A, the second row, just to clear out the denominators. So 1, B over A, 0. This actually becomes, we multiply through the second line by A, we actually get AD minus BC here, AS minus RC, and this is still R over A. Okay, but then I got to scale down to put, it's just nice to put a 1 right here. So I'm going to scale it down by AD minus BC, which also introduces an assumption that AD minus BC is not 0. Right, we can't divide by 0. So let me go ahead and put that in red here. It's just, we always want to keep track of what assumptions we're making. And okay, so 1, 0, B over A, 1, R over A, AS minus RC over AD minus BC. All right, and the last, so actually we know what Y is, right? Y is that. We could plug back in and try to solve for A, but equivalently, it's the same thing as, maybe I'll do it down here. Equivalent's the same thing as taking row 1, and if we want to clear out this and make this a 0, then we want to do row 1, and we want to subtract B over A from row 2, right? That'll clear that out and make that a 0. If you do that, it gets kind of ugly. And I don't want to do all the algebra for you. It's just some algebra. It's a little bit unpleasant, but if you do it, you get the following. I claim it simplifies to, this is RD minus BS over AD minus BC. Actually looks kind of nice. Well, I don't know if you think this is nice, but I think it's kind of nice. You get that. And so, so that means you should pause and check and try to get that yourself. I mean, you're taking this and you're subtracting B over A times this. And I claim if you work out, it simplifies a little bit and you get that. Okay, and so the answer we end up getting is X is RD minus BS over AD minus BC, and Y is AS minus RC over AD D minus BC. And I want to point out there's something kind of nice here. We're going to look at this more carefully later in the semester. I just wanted to do it now that the bottom of both of these is AD minus BC. There's also this thing here where the D's line up if you write it kind of right. And so A becomes R up here and C becomes S. And here the A and the C line up kind of right. There's just some structure to this solution that's kind of nice. The other thing, just as a last comment, is that you might want to think about make an example where AD minus BC is 0. Because this does not certainly work. These formulas for X and solution do not work. And see what happens. And I don't mean just pick the same numbers for A and B and D and C, but like actually try to, come up with an example with different numbers and what happens. Especially maybe how are the lines related geometrically? I claim there's something interesting there. Because this is always, we're just intersecting two lines, right? Okay, so think about that. We'll talk about it in class. All right, I'll stop.